Good morning, student. We have already doing the chapter gravitational. In gravitational chapter, we have done Newton law of gravitational constant, and acceleration due to gravity. Now, today we are going to discuss variation of g above the Earth surface and below the Earth surface. We are going to derive variation of g above the Earth surface. Now, let us consider a mass. Let us consider a body having a mass capital M, and from center its distance will be the capital R, and an object is placed at a distance S. Now we have to calculate g here. We have to calculate the acceleration due to gravity of above. Here acceleration due to gravity will be the g. We have already done that gm is equal to r square. And here will be the acceleration due to gravity how much? Gm. Here distance will be the r plus h whole square. Here acceleration is g is gm equal to r plus h whole square. This is equation 1. And acceleration due to gravity at the Earth surface will be the acceleration due to gravity at the Earth surface will be the g m r square. This is equation 2. Now dividing equation 1 by 2, we get g dash by g. How much we get? G m r plus h whole square divided by g m by r square. We will get g m r plus h whole square into r square by gm. This gm and this gm will be cancelled. Now r square will be the r plus h whole square. Can we write this r plus h as this r plus h whole square g dash by g gm by gr square. Now if you do reciprocal of this will be the, in exponent we have already read that if you reciprocal this power will be the negative, then this will be the r divided by r plus h by r is equal to -2. Here is a d dash by g. If you cancel this, what we will get? G dash is equal to g is equal to 1 plus h by r is equal to -2. Now this is condition of a binary expression. Now express in binomial expression. Then this will be the g dash by g. Then this will be the 1 minus 2h by r. Here look. This will be the g dash by g is equal to, no, this cancel it. So G is equal to 1 minus 2h by R. It is with G to H G into R. If you minus from this acceleration due to gravity, if you anything minus from this value will be decreased or not. From 9.8, if you minus anything, any number, then this value will be go on decreasing or not. From here we can say that from this expression we can say that acceleration due to gravity decreases above the earth surface. Okay, we have discussion about the variation of a G about the surface. Next topic is variation of a G below the surface. Next topic we are going to discuss about variation of G below the earth surface. Let us consider earth having a mass capital M, and this is O. From here to here distance is R. As we move, as we reach here this point, from here to here distance will be the D. Okay, now we are going to discuss what will be the variation of a G here. What will be the G? And here the acceleration due to gravity is G is equal to Gm by R square. Here will be the Gm R minus, here from capital R, if you minus this D square. What is the distance this? R minus D or not? So distance from the center will be the R minus D. This, let us consider G dash will be the Gm R minus D whole square, and G dash will be the Gm by R square. This will be the equation 1 and this will be the equation 2. Here, here is here we, only this path will be at this mass will be attract the body toward the center. So here we have to put M1 dash. Now we are going to find the M1 dash. Here density will be will be the will be the same. From here with that M1 is equal to density is equal to mass by volume 4 by T, and volume is sphere 4 by pi R cube. Next is M dash. Here will be the 4 by 3 pi. What is the distance? R minus D whole cubed. Here this 4 by 3 pi and this 4 by 3 pi will cancel. What the value of M dash we have got? From here we will get as M dash is equal to M minus R minus D whole cube by R cube. Now put this value in equation 1. Putting this value in equation 1. what we will get if you put the value in equal? G dash is equal to capital G m r minus d whole cubed. This will be the r cubed. And what is the r minus d whole square? R minus d whole square. This will cancel this. Then what will be left? G dash will be the gm r minus d by r cube, and dividing this value, dividing equation 4 by equation 2, we get g dash is equal to gm is equal to r minus d by r cube divided by gm is equal to r square. From you will say that gm is equal to r minus d by r cube into r square by gm. This gm will cancel, and this square and this square will cancel each other. Then what will be left with us? Here g dash by g is r minus d by r. From here we say that g dash is equal to g is equal to r by r is equal to d by r. G, this will be the 1, and this will be the g is equal to 1 minus d by r. Here g dash is equal to, from g, if you minus anything, it value will get decreasing or not. From this equation, I think this will be the equation 5. From this equation, we say that acceleration due to gravity will decrease below the earth and from equation 5 if we say that if this body will reach to the earth surface, what will be the acceleration due to gravity at the center of the earth? At the center of earth, what will be the acceleration due to gravity? G is equal to 1 minus, instead of d it will be the r by r. This will cancel, this will be the 0. Acceleration due to gravity at the center of the earth is 0. Acceleration due to gravity at center is 0. For today, this much only, and next lecture we are going to do gravitational field and gravitational intensity and gravitational potential energy and escape velocity also.